Biden issued the executive order for cybersecurity, where he introduced the software bill of materials. And the software bill of materials is an essential component for creating a market for safe, secure software. I want to talk to you about what it is, a little bit of history, and the life cycle of software, how it fits in, and the SBOM ecosystem to create a larger discussion about the domain. SBOM is necessary but not sufficient to creating a safe, secure software system. And what it is actually depends on who you ask. Essentially, it is a machine-readable data structure at its core. But when you ask people what it is, they will say to you, it's a label. It's a vulnerability software mechanism. It's a bill of ingredients. It is a compliance management tool. It is a floor wax and a dessert topping. So why do we need this? Because we don't know what's in our infrastructure. There can be very small products that do nothing but shift one register left. And it is embedded across the infrastructure. We do not know what is in these products. And when you don't know what's in the product and you add a vulnerability, you don't know how to secure your products, which is why it is vulnerability management. Why do we need SBOM? Why don't we just manage vulnerabilities the old-fashioned way by trusting Microsoft? Well, vulnerability management used to be easy, right? So the first computing bug was an actual insect. Have you guys seen this before? Okay, so this was the first bug. And the way you manage this bug is you you powered down the machine, you got your tweezers out and you removed it. And these were some of the earliest patches, right? You just slightly altered the code. But then it got more complicated. The first deadly patch, the first deadly vulnerability was actually a usability failure where in 1985, doctors came out and said, this radiation therapy machine's not working. Half a dozen radiation poisonings later and one actual radiated to death, it was fixed. So as vulnerabilities began to proliferate, we created the Computer Emergency Response Team, which was a safe place to report vulnerabilities because back then you could get arrested for reporting one. But the thing is, they kept them secret. So the time to fix them took up to 2 years. Some of them were fixed quickly, took up to 2 years. They're still out there. This was like November 1st. OpenSSL 3.0x branch. You can look at this and you can be frightened because, client OpenSSL, you connect to this all the time. What can you do? Are you exposed? You don't know. In some sense, it's not the bad old days, but in some sense it is. There was the vulnerability in the St. June remote pacemaker where you could change people's heart rates, and they denied it. And then they threatened to sue the people that disclosed it, and then they fixed it. So there's still problems with individual bugs, but the real problem is that we're now at a scale beyond the capacity for human evaluation. We are now at 20,000 bugs for 2022, and the year is not over. So I know many people have these, hockey stick. This is our hockey stick graph. So why do we need SBOM? Because without it, we can't know what's in the code. We can't know what's in the code. You don't know if it's vulnerable. And when you purchase code, you don't know what its history of vulnerabilities are. If it's likely to be vulnerable in the future, if it embeds extensive amounts of stuff, and then if there's a vulnerability, should you take action? So SBOM, depending on where you sit in the life cycle, is what it is. If you are generating software, then it's a documentation challenge. If you're verifying software, then it's a PKI issue. If you're operating software, then it's vulnerability management. And if you're evaluating software to purchase, then it's a software label. Where does it fit in the ecosystem and how do we generate it? How do you generate them? Well, you have to identify components. That sounds easy, right? You confirm the coverage, what could possibly go wrong there, and you prune it if it's not used. And the software lifecycle in theory is very clean. You do some planning, you develop an architectural design, and then you develop the software, and then you test it, and then you release it, and it's all done, and it's all beautiful, except for it never really works like that. It's more like develop new features, find some bugs, develop, oh man, that does not work at all. Let's try this other thing. Wait, people are downloading it. So how do you deal with this when you want to support developers so they can generate so they can generate an appropriate SBOM? Well, we have had other areas which are challenging for this, the information security workforce. So one way we can learn is from app permissions, and another way we can learn is from access control. I am not claiming that either one of these areas is solved. I am only saying that these are areas where a lack of developer support has shown chronic systematic problems, and we can learn from these problems. So what about apps? If we think about permissions, the advantage of permissions over SBOM is that permissions are already labeled: normal, harmless, dangerous, and system. We don't have that for SBOM. Maybe we could develop it, but it doesn't exist. So there's already information that makes it easier for developers, but they still irrationally overprivilege. They still create apps that systematically ask for more data than they need, that ask for permissions that they don't use. It is a chronic problem, and there's no reason for them to do it because there's only cost in including these packages. It makes your app bigger. There's no benefits, and often there's no data use. In fact, when they look at it, they find deprecated permissions the code can't use. And why do they do that? Because, shocker, developers are people too. They have permission naming confusion. They have inheritance confusions. So I'm not sure what permission of these 8 that I need to make my app run. So I'm taking all 8 of them. That, of course you would. And the bundling of permissions. Often you need one permission, but you get the entire class. It is a counterintuitive problem because you'd think people would only want to include the permissions they needed. It's common on Android. There have not been systematic studies on iOS, but the same app should use the same permissions. But iOS and Android have different permissions, and they have different names for some of the same permissions. So what happens is identical apps actually ask for very different permissions. So you are going to see some of the same things with identical apps having very different inclusions, even if what they're looking for is the same function. So some of the problems is that code samples include permissions. So you think, oh, I've got to solve this problem. Let me try solution A. You copy in all the permissions, you run it, it doesn't solve the problem. I want to solve this problem. Let me try solution B. You copy in all those permissions, and then you're trying the problem. By the time you're at L and it's actually working, you have a huge number of permissions. Much of the permissions overprivileging comes from Stack Overflow. And we know that people aren't doing this to grab data because they use deprecated permissions. They use permissions that don't even exist anymore, and permissions that are fused together. So you're going to see some of the same things happening when you start looking at SBOM, that people are doing human developers are people and they do human things. The other thing that I want to ask you to look at is access control. The MUD is a manufacturer usage description per device access control. And it's for secure onboarding. That's all it does, secure onboarding. So you should be able to identify and integrate devices without manually customizing your firewall. And it can be expanded to use SBOM for the location and identification of SBOMs. So you get the MUD, the IETF has expanded the MUD standard to include an option to include the software bill of material with the access control list. So here's an example of a light bulb. So obviously no human is going to read this, but what does this actually say? Your light bulb can connect to example.com using TCP IPv6 and over port 444. So this is the kind of information you might want to give a person, but even with these MUD files, it did not work very well giving people that information. So we built a MUD visualizer. It's on GitHub, and it takes MUDs and open source icons, and it maps it. Says, here you are. So for example, we had the friendliest crock pot in the world. It connected to everything. If you own that crock pot and somebody connects to it with their phone, they own your house. So you don't want that to be true, right? You don't want crock pot over here connecting to everything and also to the entire internet. This is definitely a thing I have seen. So when we just went from this and which is saying that to this, we ended up, we asked a bunch of people, of course, they were computer science students because that's what we do. To evaluate them, we found this is the correct evaluation only for people with the visualizer. And these are people who had taken network programming. They had to take a little science quiz, code quiz first. And so it made a huge difference. And so the idea is that we're going to want MUD files to publish SBOMs. How do I publish my SBOM? How do I tell you that that connects to that light bulb? That is completely orthogonal. When do I generate an SBOM? How do I know what I should name it? Right? If you have people name their own SBOMs, they're going to name it Frodo. Let's be honest. We know that from history. And ensure there are no conflicts so that you and I are both naming a package MUD visualizer because we're both working on it. It's a good name. So our SBOM visualizer concept is like this, so that you can simply look at it and tell what is connected. There's not a visualizer right now. The other thing we are looking at is a differential SBOM, so that when your code is changed, particularly open source code by third parties, the developer can just look and say, hey, bingo buffer was added and I don't need bingo buffer. Why is there bingo buffer in there? Or if you are a purchaser, and I'll talk about that later. So verifying SBOMs includes locating a correct SBOM, which we've talked about, but verification requires static analysis, file analysis, and runtime analysis. I will do a shout out to the developers of Cyclone and SPDX that they are including cryptographic attestations that are that have post-quantum option. Yay, crypto agility. Woo. I don't like sports. I have my things. So finding the correct SBOM, we talked about that with MUDs. You also may want to fingerprint the server, confirm there's not a man-in-the-middle attack, validate the PKI chain. These are all known challenges. Confirming that there's no man in the middle, validating the PKI trusted chain. I mean, I don't think anything illustrates that as well as the ransomware attack and the invasion of the Ukraine. And so you might say, all right, we're going to help developers and they're going to do this right. Why would anybody be motivated to man in the middle? Why would people want to create SBOM errors? Well, advanced advanced persistent threat actors, I cannot say that 3 times fast, can include code with known vulnerabilities if they get it out of the SBOM and you won't know to patch it. Developers simply lack expertise. They're developers. They're not, org theorists. And inclusion of unneeded code, which I talked about quite a bit just now. So there's a major issue that we might find for creating SBOM errors that has always been found to be strongly motivating. And one of those is people are talking about using SBOM to solve the open source sustainability problem, so that when you have code that is widely used, you not only identify it for vulnerabilities, but also for payments. So maybe I write a little piece of code and it turns 1 bit on the entire screen from, red to pink. And I shove it in everybody's code and it's totally pointless and useless. But if you use SBOM, I get the money. And also, if fewer dependencies begin to be valued by consumers, there's a systematic motivation for producers to misinform. So once we have SBOMs, how do you operate with SBOMs? Okay, hold on to your desk. This is the TLA part. So you want to integrate it with threat model. You want to map vulnerabilities to services. You want to enable mitigation. That makes it part of a larger ecosystem. So when you go forth and want to study SBOMs, you're going to see a lot of acronyms. But if you think about them as building blocks, it's much easier. So there is the common vulnerabilities and exposure, which list associated announcements per vulnerability, right? So this is per vulnerability. These list only unknown binaries, unknown vulnerabilities and binaries in open code. If it gets to CVE, it is a big deal. They do not list things like cross-site scripting. Those things are not in CVE. So it's a threshold that it has to be serious enough to have a CVE. And then once we know that vulnerability exists, there's a common vulnerability scoring system where higher is worse. So it's got to get a CVE and then it is evaluated, and that evaluation tells you how severe it is. And now we're including a listing of impacted systems. This is what is in the National Vulnerabilities Database. So we started by identifying vulnerabilities way back with CERT, and then we started ranking them, which was hotly contested. There's a big database of them now, and each one has a number, all 22,000 that we made. And then we also try to do clear, urgent risk communication, All right, so is this terrifying? This should be terrifying. That is, that's not the actual Blue Prism label they use for Log4j. It's prettier. But the thing in the middle, it looks like Casper, the friendly ghost, is coming to roast marshmallows with you. No, that is Spectre. It was a terrible vulnerability. And then the other looks like you left your Godiva chocolates out too long, but actually it's Meltdown. These, I am going to just stand here and say, are not clear, urgent, powerful risk communication that is immediately actionable by non-technical people. They are, however, kind of cute. All right. So how do you know what really matters? This is where the Common Security Advisory Framework comes in. It classifies and groups vulnerabilities. Each one of these icons is actually a set of CVEs, each of which has its own ranking that together illustrate a dangerous vulnerability. Well, now we have the Common Security Advisory Framework, and it includes all these things that we're going to see for SBOM, right? A validator, something that interprets the JSON that's the CSAF so that you can read it, and a management system that can display the details. Like all of these should, these should exist, and they should exist for SBOM. And the question is, are they working? people are not really testing these with developers, and they have recently added the CSAF SBOM matching system. Yay. So what does it match with? It matches with VEX, which is, how do you know if your system is vulnerable? So this is classifies and groups vulnerabilities. So you have an individual vulnerability that's announced, it gets a rating, it goes into a database. Now we have this framework which classifies and groups them, which I argue is better than Angry Casper. And now we have VEX, which is per system. So instead of saying, oh, Gene just showed that terrible vulnerability from November 1st, I wonder if I'm still affected. I have to look up the CVE. I know it's terrible. What chain of search would you follow? VEX, you can just go to VEX and say, am I affected? This is my machine. Here's, we have probably 4 different kinds of machines in the room. Is this machine affected? Am I experiencing this in my company? So they have not affected, no remediation, affected, turn off some services, often turn off the services. Make sure this port is closed is a common remediation. It's fixed, it's good. You know how your machine took a long time to reload last Tuesday? That was actually because Adobe also does patches on Patch Tuesday and they fixed it then. Sorry, it was slow. And then under investigation, which is not particularly helpful. And now we also have the Stakeholder-Specific Vulnerability Characterization, which provides guidance based on the mission of a given industry. What is important in your industry? Is this a vulnerability for Siemens pipe controller? That really matters if you're in oil and gas. It really doesn't matter to Google, let's be honest. They have fancy bathrooms, but not that fancy. So, and it basically breaks it down, building on VEX to track, attend, and act. The only reason they have track and track asterisks is they didn't want to have ignore, because that's like rude. So track meaning monitor, patch on the appropriate Tuesday, attend, mitigate now, act, your system is on fire, your computer will explode. Please pay attention. We might even make a little icon for it. And these decisions are made on the vulnerability and the network activity, whether or not there is an easy to download exploit in a marketplace. It's a tremendous driver of this. The technical impact, if it is easy to exploit, it doesn't matter if it's easy to exploit if it's automated, right? If it's been automated and people are buying it on crime forums, then this is going to change the stakeholder-specific vulnerability characterization, but it would not change the rating of the vulnerability per se. And then by making it industry specific, they can address how it might impinge your particular industry. So if there's some denial of service thing and you are selling bets on the World Cup, that really matters to you. If you're an oil company, hopefully you are not taking bets on the World Cup. And public being and well impact, is this St. Jude's pacemaker? Is this going to kill people? So SBOM is really required for this to work. Right now, we have an ecosystem, but without SBOM, it is untethered to practice, to reality, to what is in the code. And making SBOM works requires significant research on developers on these tools that we are developing. There's a weekly federal meetings on tool development. There are weekly meetings on standard developments. There is not a usability weekly meeting for SBOM. So I want to shout out to, are there policy people here, right? And usability people? All right. So now, how does this, my title was about creating a secure marketplace. I have talked to you about creating software that's well documented. I argued that this is the critical, essential missing piece in the larger vulnerability infrastructure, and that we need to help developers, and that we need to be careful because malicious actors might attack these. And now I'm going to talk about, I have 15 minutes to talk about the marketplace. Is there value in fewer dependencies? Can we identify differentiations? So we all know that there are, companies that are Linux shops, and there's companies that are Microsoft shops, and there's Apple companies. If you download an open source package, how is that going to change your dependency map? Are you not changing your dependencies? Are you bringing in code that has the same kind of dependencies that you've always had? That's always, you have 4 other products that uses it? Or are you expanding your attack surface? And also service-specific dependencies, you may not know how to mitigate. You need to know what service, you should know what services you are running. Knowing every port that is open, no, but knowing if you're running a service. And there are also customer-specific requirements. I want to do a shout out to SolarWinds, which is my favorite example. Have you guys heard of SolarWinds? Okay, SolarWinds was a massive subversion of America's supply chain when the FSB, which is the Russian NSA/CIA/FBI kind of, put in code. The funny thing to me is that SolarWinds had outsourced all their security to Bulgaria. A week after it was announced, there was my favorite LinkedIn post ever, which was SolarWinds hiring people for their security ops systems in Bulgaria, Russian speaking a plus. Like, I had more fun reading that job ad than any job ad I've ever read in my life. So maybe as a customer, you don't care. You mostly are not going to care. But if you're in the Department of Defense, you might care. So some customers speak in general requirements. And in general, security is a lemons market, right? We don't know what kind of resource management. I talked to you about preferences. We do machine learning for reveal preferences, but sometimes we are just constrained by our infrastructure. At the moment of purchase, you need benefit information. You may have community ratings. We don't have any risk information right now when you make a software choice. There's not a risk management. And we talked about how all this worked in previous markets. And these are literally open research questions. How do you describe risk and benefits in software? Well, previously I argued that we should learn from mobile phones and the manufacturer's usage description and other access control work. Now I want to argue that we should learn from IoT and mobile phones. So if you model people's express preferences, if you model their express preferences, you get what they want to do. So we ask all our participants, how often do you look at these permissions when you're making a decision? People want to look at the permissions. They want to have looked at the permissions. And then during the experiment, we looked at how often they actually looked at the permissions, and the graph is just a little different. So if you go with revealed preferences instead of express preferences, you can end up encouraging people to do something other than they want to do. It's like the fitness watch that's like, you don't really want to run today. Why don't you go have a donut? I mean, those are mostly my revealed preferences. And if you give people different kinds of communication, and this is an experiment we did where we made them choose 4 apps. And at the beginning, they can have an app that had a lot of positive rankings and a lot of privacy guarantees. And if we communicated them with eyeballs, which are watching you, or if we communicated them with like a frowny face, more privacy was more sadness. Or if we communicated them with locks, so you got more locks, you can see that even though the 3 columns here are the same information, it matters how you communicate to people. They don't know what the eyes meant, but they were comfortable with the locks. We did a willingness to pay, willingness to accept marketplace. That is, they had the option of being endowed with a low price and 0 privacy. And this is how the internet is now, right? A lot of things are free and your privacy is a dumpster fire. And when we did that, we let people click for more or less privacy using the same locks. And then we flipped it so that they were endowed with high privacy. And we found that our participants we gave them $25 and had them buy things so they got to keep the extra money. Our participants spent on average $8 extra for a light bulb, which is almost twice the cost of the cheapest light bulb if they were in this group. But labels may not help if you just slap them on there. It depends on how you slap them on there. That the default matters. When people are choosing software, if we present the software to them as you can get this benefit if you ignore security, it doesn't matter how good the label is, because people like defaults. We like what we have. We don't change our defaults. So this is the willingness to accept and willingness to pay price and privacy. So it made a huge difference. And also permissions are much easier to compare than dependencies. They're characterized by Android and Apple or Microsoft. They're like, hey, this is harmless. You could worry about this. You should definitely worry about this. We don't have that with software. It's going to be much more difficult to come up with an effective label for software. And whatever we do, we want to present it as a gain. Hey, this is great. You're getting more security. But does that mean fewer dependencies? Would you rather have a piece of code that's written with a lot of dependencies on known, tested, secure software, or something that a master student wrote from soup to nuts last week? I personally know the answer to that. So right now, all people see is gain. You need to show it to them when they're making their decision. If you want this to be an effective label, it's got to be presented in a manner that impinges their decision-making when they're making the decision. You can't expect them to make the decision and then go through and read the SBOM and then back up and then choose another product and go through and read that SBOM. How do you translate these findings to our problem? Well, if reading permissions are seen as a cost, reading exposure and dependencies is going to be seen as a cost. Reading exposures, then going over to rating the CVEs. I mean, just think about that ecosystem that I described. That has got to be made transparent and subject to communication. And it might be different for different entities. Now, the first standard, this was the minimal SBOM first standard, component license of component. So if there are lawyers in the room, are there lawyers in the room? Yeah, so this is about compliance. We are so tired of finding out that we wrote this code and there is GPL software in it and we are in gross violation of all copyright, right? We downloaded a bunch of code and none of it, and you can't run it legally. The version, the date, and an identifier that can be used for identity verification. So this was the first idea. Then this was the first SBOM, supplier, component, version, any other unique identifier. Ideally, this was conceptualized as, the MUD file so that you can look up and make sure that you're doing the right thing, and the entity that created the data. So this seems pretty simple. I had at the time zero confidence that that is what the final SBOM would look like. So what we did was we went and took a union of best practices for coding across the federal agencies and listed them all and went and asked people, what do you want in SBOM? And since then, by the way, the variables for SBOM for AI have expanded. So if you think that nutrition labels are complicated, this would be more complicated. But not all features are equal. So we have this little experiment, which I am happy to mail out to you if you want to participate in. Yay, I would love you to participate. And we just ask people what's important and what's not important. So here is an example, local storage category. If you have a photo app, you do not know, and permissions will not tell you if your photos are only stored locally or if they're backed up. If they are backed up, your permissions cannot tell you if you maintain your license to them or if they are used for training the company's AI on things such as image and facial recognition. And you further do not know if the company is donating them to larger scale like open AI efforts. So something like local storage might be important to you. It's also not a thing you can obtain from permissions right now. You have to read the details of the license. And if you think privacy permissions are complicated, we did this in the DoD. We only did DoD participants, and we did each individual characteristic. One reason we did card sorting is because it's a lot of variables, and I don't think a survey would have worked. And we found that there were differences within the organization. They were generally less interested in code development and accountability. But if you broke that down to the different stakeholders, so first of all, I'm arguing to you that we're going to get a label and you have to present it in a coherent, systematic way at the time of decision in a simple manner. And now I'm telling you, you cannot do that with SBOM because you need to know what the person needs to know and what their role is and why they're using SBOM, because that causes significant differences in what the person you're talking to thinks is important. And this is only people involved in DoD procurement. So we're doing a larger one now, and we are going to compare non-DoD and DoD, and I think that there are going to be differences. I am right out on that limb. So we are going to need AI to support human decision makers in all the steps in the development. And for developers of apps, they cannot be asked to generate and then read these. They need to be shown the changes, and they need to be shown the changes in a way that's readable and human-centered. And they can't be asked to identify all the dependencies that are not used. We need to use machine learning and testing to do that. We need it for marketplaces so that people can make informed decisions according to their own roles and priorities. We need to translate all of these into a meaningful visualization according to the role and the individual. And we need completely different visualizations for operators once the software is purchased and installed. So I am going to, this is my first time I've done this slide. I feel very bold that we have a new Hourglass. You know, we've had the IP Hourglass for a long time, and now we finally have a security Hourglass. Yay! It's only taken, let's not think about how long it's taken. And on the top, you can see these are all impacts, right? CSAF, SSBC, VEX, these are all about the impact and the ecosystem and how it is experienced. And on the bottom, National Vulnerability Database, the existence of the vulnerability, the ranking of the vulnerability, these are all raw data. And so without knowing what code is in a product, you can't identify the relationship between, sorry, this is the first time I've done this slide and I have a typo. Let's call it produce. Some code is fruity. And without knowing the impact and patterns and risk, consumers can't choose to purchase secure software and they can't keep themselves safe. So a market for safe, secure software requires SBOM. SBOM is not receiving a lot of attention from policy and particularly human factors and HCI researchers. And the software bill of materials, if you want it to work, it's going to require machine learning and AI. That is absolutely trustworthy because it will be attacked. So I hope this talk was indeed the bomb. Thank you for your time, attention, and feedback. Thank you.
All right. Thank you, Dr. Camp. We are now going to do our virtual fireside chat so that we can't have the fireplace that shows on an endless loop during the holidays in the background.
Oh, yeah, that's what
we need. Well, fascinating talk. I guess, let me start off with kind of a big picture question. We're at the tail end of 2022. Computers have been around for a long time. It's taken so long to get to this concept, right? So the idea's been around for some years, but it was really the Biden administration's executive order in 2021 that has kind of jump-started, the public debate and desire among policymakers and to some extent industry to try to really pin this down. What's taking so long?
I think that you don't solve a problem generally in public policy unless it is an urgent and important problem. You want to give the marketplace plenty of time to solve the problem itself. And as long as computers were being run in closed organizations and by experts, it seemed that having a market-based approach without these large-scale federal standards was adequate. And I want to say to you what has taken so long. Getting CVEs was a huge step forward. Having just the identifiers instead of I'm posting this vulnerability on Bugzilla because I'm afraid if I go to the company, I am going to be arrested. Not arresting people for reporting vulnerabilities was a big cultural change. And then, so having, yes, you report them and here's your CVE. And then now we pay people to report them. That is a huge, important change in the culture. And how important were they? Would SBOM work without these other components? If we just had CVE and the National Vulnerability Database and SBOM, it would be like, okay, here's your huge list of vulnerabilities. All right, that's too much. It'd just be cognitively and organizationally overwhelming. So we needed all the other components to be there to have this component be effective. And you need to have a strong motivating argument to go to every software user, purchaser, and developer on the planet and say, you will do this. This is a large, non-trivial burden, even if we make it very useful.
One of the things I love about this topic and your work generally is its emphasis on how a lot of technology problems clearly have a technology component. Oftentimes, it's human behavior. It's the incentives and disincentives that humans bring to decision making that has an outsized impact on risk. And as when it comes to the SBOM, maybe just to summarize a little bit, there are sort of two fairly distinct problems that the SBOM concept is trying to solve for. One is to help purchasers make informed buying decisions before they commit to a product, which of course assumes that the buyer cares about security. If you go back to Akerlof's Market for Lemons article, I play this game with my students. I teach that the idea that is the market for software a market of lemons? And my ringer question to my students is, well, okay, what if you had a coder, if you were to develop a way to bring transparency to whether or not the developer of software wore a hoodie or not during the development process, would that necessarily result in huge demand for product coded by dudes wearing hoodies? And the answer is, well, no, unless people really want that, right? And the same is true for security. And then the other goal of an SBOM is to help those who've committed to the product or at least exposed to the product to manage risk in the moment. And to me, a big part of the SBOM story is it just comes back to economics, right?
Well, yes, and you had to have alignment of the stakeholders for this to happen. The presence of licensing in the very first standard said that this is a pain point. Managing and ensuring that you're in compliance is very difficult. And if you don't know what's in your product, you don't know if you're in compliance.
Potentially exposed to
copyright. So you have that problem that people have been struggling with. And then you have purchasing secure software because there's no way to know if your software is secure or not. And with SolarWinds, most people didn't even know they were purchasing it because it was bundled in a larger package. So SBOM is described as a label, but I believe it is more like the canonical elephants that a lot of people are standing around and holding the tail and saying, look at this label, this is a great label. But actually its capacity to interact with the ecosystem as a whole is the body and the head of the standard. That I think if adopted, this is where we will see so much of the value for software users.
And what is your assessment of the likelihood at this point of SBOM concept taking root in the marketplace? Just for background, the Biden administration's executive order more or less requires federal agencies to request an SBOM. And the federal government has some purchasing power, but it's not like it was a generation or two ago. And there are even some who are skeptical at this point of the ability of the federal government through its purchasing power to drive market conditions. Do you think this concept will take off? And if you were advising the Biden administration, what would you advise them to do, assuming, as I do, at least that this is correct?
If I were to advocate for policy actions that could make SBOM take off, I would advocate for significant, of course, because I'm a faculty and that's my area. Obviously, they should invest significantly in human subjects testing and creating usable tools. So, what you see depends on where you sit. Also, if there are ever issues where a party might be liable for unpatched vulnerability, we cannot make people liable for unpatched vulnerabilities now because they may not know they're there. It would be like, oh, everyone in this room is liable for violating export controls, if they have any thread in their clothes that was produced using Russian oil. You just can't. So it depends on the drive for accountability, and it depends on the larger industry drive for accountability by the software community.
Well, yeah, whenever actors in a position to influence risk outcomes don't bear the cost of their decisions, mischief happens, right? Risk outcomes and risk decisions become misaligned. And I mean, what is, on your point about liability, I mean, I'm a lawyer by training.
I know, I use the L word.
And, I mean, in theory, right, Congress could say, actually, no, user, we are going to make, provide some liability, liability regime, and with the expectation then if users are subject to the regime, they will demand more security, right? It kind of comes back to the first use case of an SBOM, like to help consumers make better purchasing decisions. How much of this is ultimately going to depend on customers seeing value in an SBOM versus the vendors of products, of software, goods, and services, viewing an SBOM-like concept as a marketing advantage? I mean, how would you sort of weight the degree of impact that those two communities will have on the likelihood of this taking off?
I think whether or not it takes off depends on how you model that impact and what you expect. I will say that I included that last IoT labeling paper that we did to illustrate that if it fails the first time, it does not mean that labels are inherently bad. And it is often compared to a food label. If you looked at the United States today, you could argue that food labeling has been a terrible failure, that people have there's more obesity. However, if you speak to anyone who has a real need, someone who is struggling with celiac, someone who has a severe nut allergy, and ask them if it has maybe even saved their lives, you will get a very different answer. So there are definitely small organizations who are highly exposed and highly vulnerable for whom this will make a big difference. If it doesn't shift the entire marketplace, if it doesn't improve America's, virtual health, I don't think we can then call it a failure.
I was wondering about this AI machine learning implementation. So I guess it would imply all the codes stored at class.
Well, that is an open question that is the manufacturer's usage description is trying to resolve. That if you have multiple SBOMs, can you make that comparison? Because there's not one software marketplace. And I think that is an area where, and this makes me very happy, you definitely see some entrepreneurship where people are saying, oh, we'll give you our SBOM and you can see that we are not including any garbage code. So, but decision-making is going to require, 20,000 is tiny for AI, but And you take 20,000 vulnerabilities and you compare it to millions and millions of lines of code. 20,000 is already too much for a human. And then you search those lines of code, and then you go over to VEX and then find out if you need to take action. And then maybe you don't believe VEX and you take the framework and find out if it's being traded on e-crime. And if you think the SBOM is a problem, scraping and infiltrating and observing e-crime forums, open forums is pretty straightforward. But many of these are vertically integrated, large-scale e-crime firms, like the Conti Slack database. It's very hard to observe that. So you're going to have to do a lot of guessing about what's happening in closed marketplaces by what's happening on the network and what is happening on open marketplaces. That is an area where only AI has a hope of detecting.
Well, we are at the end of the hour. I want to thank you all for joining us, both here in the room and those on Zoom. Just a reminder that we have 2 more seminars in our fall series. On November 29, we'll have Ronald Robertson from the Stanford Internet Observatory with us. And then on December 6th, Karen Nershi, also from the Stanford Internet Observatory, for a pair of what look to be fascinating talks. Our winter series will begin on January 10. And with that, please join me in thanking Dr. Camp for joining us.
Thank you for showing up on Tuesday before Thanksgiving. And I'm very interested in future SBOM research, so please feel more than welcome invited to reach out. Thank you.